In this question, we're going to prove that if we are given y as an odd integer, we want to prove that 8 divides y squared minus 1. To prove this result, we're going to use some other results before that. First thing that we will have to use later is that we're going to prove now that k squared plus k is always even for any k in Z. Okay? So we're going to prove this result. But before, let's see if this is true. This result that 8 divides y squared minus 1. Okay, when y is odd, okay, let's say that y is 1, so 8 divides 0. If y is 3, so we have y squared minus 1 is 9, is 8. 9 minus 1 is 8. So 8 divides 8. If y is 5, we have before that's 25 minus 1, 24, and 8 divides 24. Okay, and the next one is 7. 7 squared is 49 minus 1, that's 48. And 8 divides 48. Okay, and we see that this result seems to be true. So, but we need to prove it using algebra and some basic results from number theory. The key idea here is that we want to prove this result here is that k squared plus k is always even for any k integer. Okay, so we have two cases here. Either the first case is that k is even. Okay, if k is even, we can write k as 2a, where a is in Z. Okay, in this case we have k squared plus k is gonna be 4a squared plus 2a, and if we factor out by 2, we're gonna get 2a squared plus a, and if we let this one equals m, so that means we have k squared plus k is 2m. That means it's an even number. Okay, the next next case is that k is odd. If k is odd, that means k is gonna be 2a plus 1, where a is in Z. And therefore we have k squared plus k is gonna be 2a plus 1 squared plus 2a plus 1. Okay, if we do some algebra, we're gonna get 4a squared plus 4a plus 1 plus 2a plus 1. This is 4a squared plus 4a plus 2. If we factor out by 2, we're gonna get 2a squared plus 2a plus 1. And if we let these ones be some m, we see that k squared plus k in this case is 2m. That means this number is even. Okay, so in both cases, and these are the only two cases that we have k is odd or even, we have shown that k squared plus k is always even. Okay, now we want to prove the result here. Okay, so for y odd integer, that means y is, we're going to prove that 8 divides y squared minus 1, where y is odd integer. That means y can be written as 2s plus 1, where s is in Z. Okay, and if we square y, we're gonna get 4s squared plus 4s plus 1, and if we add minus 1 to both sides, we're gonna get 4s squared plus 4s. Okay, now can we conclude that that 8 divides y squared minus 1? Can we do that? Yes, we can, because we have 4 times s squared plus s, and s is in z. And what did we say about this number, s squared plus s, which is k squared plus k for k in z. So this one can be written as, we said that s squared plus s is always even. That means we can write this number as 4 times 2, let's say b. That means y squared minus 1 is 8b. Okay? That means 8 divides y squared minus 1. And that's what we need. Okay? This is the result that we needed to prove. Okay? We used some algebra and some results, and a result that we have proved to show that 8 always divide y squared minus 1 if y is an odd integer. Okay? This proves the result that we need. Okay? Remember that to prove this result, we had used this fact, okay, that we proved. We used the proof by cases. Okay, we had 2 cases, and we proved that this one is always even. And we had used this one here. So once we get here, we had s squared plus s, or k squared plus k, and we know that this is even. That's why we had to write it as 2b. And once we did that, we get 8b. That means y squared minus 1 is 8b. That means 8 divides y squared minus 1. And this is what we needed to prove. If you see any errors or mistakes, please let us know. Okay? And please like, share, and subscribe. Thank you again.